All right, we're back. We're here. Be sure to get your local kombucha, your local overpriced kombucha, and we're ready for another geometry nodes and shading lesson, which is kind of the main points here. We are going to go on lighting, very little on lighting because it's just incredibly simple, which this course is very much showing that simple lighting is very effective with motion graphics. We're going to be building out a whole kind of plexus style system within geometry nodes, and we're going to learn a little bit about that, kind of 3 different parts, attaching them and having them move in harmony together and talk to each other and all that fun stuff. And then this is going to be a big lesson on shading. That's kind of why I created this lesson in the first place, was to have a lot of shading, like procedural material stuff in this particular lesson. So it's going to be pretty hefty. So that'll be part 2. Part 1 is geometry nodes. So we are in part 1. Let's build this thing in geometry nodes. So we are here in a blank document, and let's hop into geometry nodes and kill this window here. So we're going to go ahead, hit Shift A. Let's go ahead and throw in this plane to get things started. We're going to click new, and here we go. So let's go get a plane, or in this case, a grid, and throw it here. And then all of these guys, give it a scale of 10 and give yourself 10 vertices, which is going to look like that if we go to the wireframe view. All right, so there's a lot of things that I want to think about here. One is I do want to get some separation of geometry. I want this to be triangles and not square faces, so we're going to need to triangulate. We're going to need to separate geometry, points on faces. We're going to be making a wireframe. So all these kind of things are going through my head as I'm building these, and especially when I built this lesson in the beginning, that's what I was thinking. So first thing I want to do is go ahead and displace this guy. So let's create our displacement system. So of course the gatekeeper node is a set position node, and we'll throw that here. We are going to need a combine XYZ because we need to be able to access the Z, this guy right here. And so this combine XYZ allows that to happen. Let's get in a noise texture. So NOI, and plug him into the Z. Now we have that, and I know the detail, I like there to be no detail in this particular one. And let me show you the difference. If we go here from 3D to 4D, here's how it looks like with detail at a value of 2. It's moving, it looks fine, but if I bring my detail to 0, it is a much more, I guess, less detailed movement. It's bigger movement. So you see you have a bunch of little, we'll do a detail of 2. With the detail, you see you have a bunch of smaller ones, and there's more movement. If we bring detail to 0, it's much more uniform, or whatever word is applicable for this. So that's why I like 2. And we're going to need to get a vector math node, VECT, a vector math, switch that over to multiply so we can multiply what's going on here. So that is going to be our strength slider essentially. So now we have this, and we have this guy ready to be separated. But here's the problem. With a plexus style looking thing, we need triangles, and these are squares, right? So if we create the wireframe, we create the the decimation, basically, it's not going to look like a plexus style. And so if you don't know what plexus style is, just go ahead and Google plexus style motion graphics, and you'll see these triangular things, and it's really cool. It's kind of like this neural network looking thing. So this is very much inspired by that. And so we are going to need a triangulate node right here, TRYAN, triangulate, to allow, whenever we decimate things, to decimate them from triangles and not squares. Now we have this. So the first thing I want to do is go ahead and separate geometry from the grid right here before we get to the triangulate, to kind of kill bigger chunks of it. So what we're going to do is get in a separate geometry node. And in this case, we're going to go ahead and separate faces instead of points. And we're going to get a random value node, because there's no use in using a noise texture for this, because it just needs to be totally random. We're going to go to float to Boolean, so we just get a slider. and plug that right into selection. So now we have this going on. And so what I would do is just play with your probability until you like how many pieces are missing. We're going to go right about here, and then you can play with your seed to see if you like it. I actually liked this initial look, but we will certainly change it as we go on. So the first thing I want to do is to create my wireframe system. So we're going to create what I like to call a procedural wireframe. We're going to need to get a mesh to curve. So we can convert our mesh into a curve, which is going to do this. And then we need to get a curve to mesh. And if this is the first time you're seeing me do this here in the course, essentially this guy turns this guy, we'll take him off here. This mesh to curve, if I mute it, we have a mesh. We'll unmute it, and I'm hitting M. If we unmute it, it turns it into curve. So every I guess this would be edge. Every edge turns now into a curve with no geometry on it. Now it's just a simple curve. So if I were to render this, nothing would render. There is a curve there. So now we have to go, okay, how do we now put geometry onto the curve? And that is with a curve to mesh. Now there's two things you can do. You can get you can get a curve circle, if we can find it here, but I think I just have to type in circle. You can either get a curve circle, or you can get a curve line. So these two things are going to create geometry. So you plug curves into profile curve. Profile means what's the shape of the geometry we're about to throw onto here. So what you could do is throw a circle curve on there and then bring your radius down, and you now have your wireframe. But that's because this is a circle. So the size of the circle is going to be the size of the tube. Or you can throw a curve line on there, and it's going to be weird. But what we can do is just go ahead, turn on the X here, and now it creates a line. Now in this case, it's not applicable. It doesn't look that great. But if you had just like straight curves that were displaced, I'm going to throw it up here. I have a tutorial on YouTube where I created all these curved lines and then extruded them up. So feel free to watch that. It's a really cool one. And that's where we used this technique where we use a curved line, and then I used a solidify modifier and a bevel and made it look awesome. But in this case, we want to create a wireframe with this, and I'm actually going to do 0.005 on the thickness. Now we have this. We have our wonderful little wireframe. Now I want to put circles on each available point. So we're going to get a join geometry, and we need to get an instance on points. Which is going to allow us to put a point on everything. And here's a really important thing to know. If I were to go ahead and say, hey, let's go to the set position. So I want it to, let's create chaos here. Let's use right here on the mesh. I'm in the grid. Let's just throw it here on the points. And then we're going to get an icosphere. And then we'll plug that into instance. And then we'll plug the instance on points into the join geometry. So we have our subdivisions bring our radius. So this is what we have, right? That's because we plugged the grid. We bypassed all of these edits, put it straight into there. So actually nothing's going to happen, right? I'll animate my W, but the circles are not attached to this guy. So, okay, well, we need to put it on where it starts to displace, which would be the set position. Okay, let's do here. Now we have this. Now they are set on it. And that's because we have this separate geometry and we have the set position. And now it is actually linked to it. So now when we change our edits, it is linked in the proper spot. So you might go, oh, well, I want it on all the points. The grid is the points. Yes, but we made some changes. So you wouldn't want to put it on the mesh to curve. Like for example, so if there were some other edits, like if I put the curved circle into points, it wouldn't work. It'd be weird. So I'm going to go ahead and we are going to use all the way into the triangulate. That is the last edit before we did other things. And so that's where I want to place it. So now we have the points in the places we want and it's moving correctly. So keep that in mind when you're putting things on points. Where do you want points? Make sure you keep it there. Now, here's where my head is at. I want to fill in a couple of these spots. I want to have a couple like bare wireframe things, but I want to fill in some of these triangles. How am I going to do that? So what I do know is I need to go ahead and fill it back in, and then I can delete geometry once again. So the way I'm going to do that is let's go ahead and get a separate geometry node here. This is our gatekeeper to do that procedure. And so what we're going to do is right here on triangulate, plug that into geometry. We're going to go here from point to face, tell it what do we want to delete, and then plug selection into geometry. Now we can go ahead and say, all right, we need a random value node to tell it, how much and where to delete. So let's go ahead and get a random random value. We're going to go from float to Boolean and plug that into selection. And now we're able to delete some. And you can go ahead and say, how much of these do you want to delete? I just want it to be kind of random. And again, you can play with that seed value to change it further. Here we are. We now have this going on. And then I can go ahead and say, I want to get in a set position node right by this set position node because I want to bring it down a little bit. There we go. And then we can play, okay, this is working all right. All right, now I want to point out a problem that I just realized as I'm recording. I could consider just re-recording this to alleviate that mistake, but I guess this is a good learning opportunity. If I go ahead and I play with the W here, notice it's kind of jumpy. See that thing? The triangulate is moving. Watch right here. The triangulate kind of changes. And that's because I put the triangulate after the set position. That is the problem that this now creates. The triangulate, we want the triangulate to be stable before we set position. But since it's after, every time we move the W, things are changing. It's not great. So what do I need to do? Well, I need to know where is this thing being plugged everywhere. So this separate geometry, this mesh to curve, and this instance on points. So what I'm going to do is I'm going to hit shift and right click so that I don't have to go and replug everything. We can just plug it right into here. And then I'm going to put the set position into this, which is going to go back to faces, and put the triangulate. Woo, here we go. Right here. So now when I play with it, it's now completely stable, right? Now, I could have just re-recorded this, but I figured, hey, let's show a little bit of problem solving. But I think it explains really well understanding the hierarchy of your nodes, of where things are. Because again, like I mentioned, if we were to put the triangulate over here, we are displacing and then we are triangulating, thus making the displacement change the triangulation every time we move. I don't want to do that. I want to displace the triangulate. I don't want to triangulate the displacement. So there we go. Problem solving. We have now added problem solving to this lesson plan. Honestly, it's a gift. So there we go. We now have this. Not a big fan of the fact that there's no faces over here. And the way I can do that is just bring in my probability. And then maybe we can random seed that. Ooh, I like that. Maybe bring it more probable. Cool, this is sick. All right, we are done modeling. All I want to do now is just animate the noise texture. Then we can move on to shading. So let's do that. Let's bring our W to 0 on the noise texture, and let's animate our W. Just from experience when I designed this, I know I'm going to want 300 frames because I liked that speed. So we're going to do 300. The more frames, the longer the animation is going to be, so the slower our displacement will animate. So here's what I'm going to do. I'm going to go ahead and duplicate our noise texture, and I'm just going to give myself a lot more space. Typically, I'd want to just cut it in half, but we're just going to deal with this. We're going to get in a mix color, put it here, and plug this guy here. Now be sure these guys are precisely the same. Otherwise, it's not going to work. So I'm going to go right over here. This is our timeline. So I'm going to go back to frame 0. Be sure that in your preferences, in the animation, their default interpolation is linear. All right. So I'm going to hover over here. I'm going to hit I, and then on this guy, hit I. And then if you want to see that there's a keyframe, you can click here. And then we're going to go to the very end to frame 300, and I'm going to type in a value of 1, I, bring it over, I. Make sure you get 300. I'm going to hit I on the W, go back. I'm going to hit the back arrow to frame 0, -1, enter, and then hit I. And now we have a looping animation. I'm going to go to the very end of the timeline to make sure. Yes, it loops. I think I want to make my displacement quite a bit stronger. So we're going to do something like this. There we go. Nice. And then you can also get a set position. We can just get another just bare set position node to bring him down here. There we go. Now we have this, our animation. He's animation and he's animationing. So we like it. I'm going to pause part 1 here. I'm going to go ahead and save this project file. So in case you come back later and you lost the file, you'll be able to start where I'm starting in part 2. So let's head over to part 2 and create the materials and the lighting for this animation.